Welcome, everyone. I'm thrilled to have you here today. Let's get started on mastering cloud deployment models. Welcome to our deep dive into cloud deployment models. As a senior cloud architect, I often see organizations struggle not with the technology itself, but with choosing the right environment for their specific workloads. Looking at our first bullet point, the what, a deployment model simply dictates where your infrastructure lives and who owns the hardware. The basics revolve around three core pillars: public, private, and hybrid clouds. But the why is where it gets critical. Selecting the right model isn't just an IT decision, it's a business strategy that directly impacts your capital expenses, your compliance capabilities, and your agility. How do we make this choice? We meticulously evaluate workload requirements. Does the application experience wild traffic spikes? Does it handle highly regulated healthcare data? These questions drive the decision. Finally, for our deep dive, remember that your choice alters the shared responsibility model. Moving to a public cloud offloads physical security and hardware maintenance to the provider, freeing your team to focus on innovation rather than changing out failed hard drives. Let's lay this foundation before exploring each specific model. Let's direct our attention to the flowchart on the screen. This diagram visually breaks down the core concept of cloud deployment models into a simple, easy-to-digest structure. At the top root node, we have the overarching concept of cloud computing. Flowing downwards, you can see it splits into three distinct paths representing our primary models: public cloud, private cloud, and hybrid cloud. Notice how the public cloud node connects to characteristics like shared resources and an OpEx or operational expenditure cost model. To the right, the private cloud node branches into dedicated infrastructure and high control, highlighting its isolated nature and typical capital expenditure model. Finally, right in the middle, the hybrid cloud node bridges the gap, pulling in capabilities like cloud bursting and truly offering the best of both worlds. This visual map is your mental anchor for today's training. Whenever you are evaluating a new workload, picture this diagram to remind yourself of the core traits and financial models of each distinct environment. Let's transition into our first specific model, the public cloud. When you hear public cloud, think of providers like Microsoft Azure. What exactly is it? It's a vast pool of computing resources delivered over the public internet. The basics of this model rely on multi-tenancy. Imagine an apartment building. You have your own secure, locked apartment, but you share the building's underlying foundation, plumbing, and electricity with others. That is multi-tenancy. Why is this so attractive to businesses? Because it completely eliminates upfront capital expenditure. You don't need to buy servers or lease data center space. Instead, you gain access to virtually infinite scalability. How do you use it? You simply log into a portal or use APIs and provision what you need in seconds, paying only for the exact compute or storage you consume. When should you use this? It is the absolute gold standard for applications with unpredictable traffic patterns, rapid prototyping where you want to fail fast, and general enterprise applications that don't require custom, dedicated hardware. Looking at this diagram, we illustrate the multi-tenant nature of the public cloud, which is crucial to understand. On the left, we have Organization A, Organization B, and Organization C. They represent completely different, unrelated companies. Notice how all the arrows flow over the internet into a single, unified public cloud provider boundary. Inside this boundary, the provider manages massive pools of compute, storage, and platform-as-a-service offerings. The magic here is logical isolation. Even though these organizations are sharing the same massive data center and potentially even the exact same physical server rack, their data and applications are strictly logically isolated from one another by the cloud provider's hypervisor and security controls. This architecture is what allows cloud providers to achieve massive economies of scale, driving down costs for everyone while maintaining enterprise-grade security and reliability. It is a shared, yet highly secure, ecosystem. To really cement this concept, let's look at a highly practical, real-world use case for the public cloud, a global e-commerce platform. Imagine you are the lead architect for an online retailer. During events like Black Friday or regional holidays, your traffic spikes by 500%. The traditional challenge here is that if you buy physical servers to handle that massive Black Friday peak, those expensive servers will sit idle and collect dust for the other 10 months of the year. That is a massive waste of capital. The solution is strictly deploying your web frontend on a public cloud. How do we execute this? We configure intelligent auto-scaling rules. We tell the cloud provider if the average CPU utilization of my web servers exceeds 70%, automatically provision and add more servers to the cluster. When the traffic dies down, the rules automatically terminate those extra servers. The outcome is pure financial efficiency. You are paying for that massive compute power only during the exact hours or days your customers are actually hitting your site. Let's walk through the sequence of events in this e-commerce scenario using this sequence diagram. At the top left, we start with our global users initiating a massive traffic spike. Think Black Friday morning. This traffic hits our public cloud load balancer. The load balancer detects that the underlying servers are working too hard, specifically passing a 70% CPU threshold, and alerts the auto-scaling group. Automatically, without any human intervention from your IT team, the auto-scaling group provisions brand new virtual machines. Once ready, they signal the load balancer, which immediately starts distributing the heavy traffic to these new servers, resulting in a smooth checkout experience for the users. But the most important part is the node at the bottom. When the holiday ends and traffic drops, the auto-scaling group detects the low load and automatically destroys those temporary VMs. The billing stops instantly. This sequence perfectly illustrates why the elasticity of the public cloud is revolutionary for variable workloads. Now, let's shift gears and examine the private cloud. If the public cloud is an apartment building, the private cloud is a custom-built, single-family home. What is it? It consists of cloud computing resources dedicated exclusively to one single organization. The basics define it as a single-tenant environment. It can be physically located in your own company's on-site data center or hosted by a third-party provider who dedicates specific hardware solely to you. Why go this route? Ultimate control. You have total authority over security protocols, strict compliance adherence, and specific hardware requirements. How does it work? Usually, your internal IT team takes on the role of the cloud provider. They manage the physical hardware, the virtualization hypervisor, and the portal that internal developers use to request resources. Our deep dive here is about responsibility. Unlike the public cloud, running a private cloud means you are entirely on the hook for capital expenditures, replacing aging servers, and maintaining the physical security of the facility. Take a look at this architectural representation of a private cloud. The most prominent feature of this diagram is the thick, dashed boundary line labeled Strict Organizational Boundary. Everything inside this box belongs to, and is used by, only one company. Internal users access the resources through a dedicated private network or firewall. There is no exposure to the public internet by default. Inside, you see dedicated compute hosts and dedicated storage SANs. These aren't shared with any other company. This hardware runs your custom legacy apps and highly sensitive databases. By visually encapsulating these resources, the diagram highlights the core value proposition of the private cloud: absolute isolation. If a regulatory body demands to know exactly which physical hard drive holds a specific piece of data, a private cloud architecture allows you to point to the exact rack in your data center, providing a level of physical auditability that public clouds abstract away. Let's contextualize the private cloud with a critical real-world use case: healthcare systems. Imagine you are managing the IT infrastructure for a national hospital network. Your primary asset is millions of electronic health records, or EHRs. The challenge here isn't just technology, it's the law. You are bound by incredibly strict regulations like HIPAA, which demand absolute data sovereignty, physical auditability, and uncompromising privacy. You cannot risk multi-tenant data leakage. The solution is designing a robust private cloud within the hospital's own geographically secure, heavily guarded data centers. Execution involves deploying a custom virtualization stack. Because you own the hardware, you can implement physical hardware-level encryption and specialized, deep-level audit logging that a public cloud might not expose to you. The outcome is powerful. The IT team provides doctors and researchers with a fast, cloud-like self-service portal to spin up applications, while the compliance officers can sleep at night knowing there is 100% data isolation. This flowchart illustrates the highly secure flow of data in our healthcare private cloud scenario. On the far left, hospital staff initiate a request over a secure internal intranet, completely bypassing the public internet. This request hits the strict IAM and firewall security gate. From there, traffic flows through encrypted tunnels directly into dedicated compute nodes. Notice the box labeled Compliance Zone wrapping around our compute nodes and our encrypted dedicated storage (SAN). This visual grouping represents the physical and logical perimeter that satisfies regulatory auditors. Because this entire infrastructure is privately owned and operated, the hospital network can guarantee that no external entity shares this storage array, ensuring that patient data never crosses paths with outside corporate data. It perfectly maps the business requirement for extreme privacy to the technical architecture of a private cloud. Now we arrive at the most dynamic deployment model, the hybrid cloud. What is it? Simply put, it is an interconnected environment that seamlessly links an organization's private cloud with a public cloud provider. The basics revolve around workload portability. Data and applications can dynamically move between these two environments based on changing needs. Why is this so powerful? It offers unparalleled flexibility. You no longer have to choose between the absolute security of a private cloud and the massive scale of a public cloud. You get both. How is this achieved technically? The private and public environments are stitched together using highly secure, encrypted VPNs or dedicated private WAN links, such as Azure ExpressRoute, making them act as one single network. When is this appropriate? It is the absolute best choice for phased legacy migrations where you can't move everything at once, for implementing robust disaster recovery, and for intelligently handling seasonal traffic bursts without over-provisioning your local data center. Let's explore the architecture of a hybrid cloud using this diagram. You'll immediately notice two distinct zones. On the left, we have the gray private cloud representing an on-premises data center, housing core legacy systems and a sensitive SQL database. On the right, we have the blue public cloud hosting the web front-end and an analytics engine. The most critical component of this diagram is the bidirectional arrow connecting the two, labeled Secure VPN/ExpressRoute. This represents the high-speed, encrypted tunnel that unites these separate worlds. In this design, a user can hit the highly scalable web front-end in the public cloud, which securely queries the sensitive database kept safely on-premises. This diagram perfectly encapsulates the hybrid philosophy, placing specific workloads exactly where they belong based on security, cost, and performance requirements, while ensuring they function together as a unified, cohesive system. To demonstrate the true power of the hybrid model, let's look at a highly effective strategy known as cloud bursting for a major retail chain. The scenario is that this retailer runs their steady, day-to-day operations on a private cloud. They know exactly how much compute they need for 10 months of the year, so it's cost-effective to run it locally. The challenge: holiday shopping events. A massive sale will completely overwhelm their local data center, and buying new servers for a 2-week event makes no financial sense. The solution is to architect a hybrid cloud bursting mechanism. Execution works like this: intelligent load balancers continuously monitor the local private cloud. When capacity hits a danger zone, say 90%, the system automatically spins up identical web servers in the connected public cloud and seamlessly routes the overflow traffic there. The outcome is beautiful. Highly secure, baseline operations stay on premises, but you leverage the infinite scale of the public cloud precisely when you need it, avoiding outages and saving millions in capital expenditure. This state diagram provides a brilliant visualization of how cloud bursting behaves dynamically. We start on the left in the normal operation state. During this time, the private cloud is active and the load remains safely under 90%. The system is stable and cost-contained. However, follow the transition arrow labeled Traffic Spike Detected. This shifts the entire system into the cloud bursting state. Inside this new state, we see that the private cloud is maxed out, but instead of crashing, it activates the public cloud overflow. The hybrid connection allows the public cloud to absorb the excess pressure gracefully. Finally, follow the bottom arrow back to the left. Traffic normalizes. The system dynamically scales back down, shutting off the public cloud resources and returning to normal operations. This visual flow demonstrates the automated, reactive nature of a well-architected hybrid cloud, shifting states to protect application availability while optimizing costs. To wrap up our training, we must introduce an increasingly popular evolution of cloud computing, the multi-cloud strategy. What is this? It involves an organization intentionally using multiple different public cloud providers simultaneously, for instance, running workloads on both Microsoft Azure and another provider. The basics here involve purposefully distributing your applications to avoid vendor lock-in, meaning you aren't entirely dependent on a single company's ecosystem. Why do organizations do this? It allows architects to cherry-pick best-of-breed features. You might love Azure's Active Directory and enterprise integration, but prefer a different provider for a specific machine learning tool. How is this managed? It requires highly sophisticated, cloud-agnostic orchestration tools to manage deployments across varying APIs. In conclusion, remember your core use cases. Use public cloud for unmatched elasticity and scale. Use private cloud for absolute isolation and regulatory control. Use hybrid cloud for dynamic flexibility and cloud bursting. And consider multi-cloud to maintain vendor independence and access specialized services. Let's look at our final diagram, which illustrates a complex, modern enterprise IT landscape. At the top, the enterprise organization is branching out into 3 distinct environments. It directs identity and enterprise apps to Microsoft Azure, sends specific AI workloads to public cloud V, and keeps legacy secure data in an on-premises private cloud. This perfectly visually represents a combined hybrid and multi-cloud strategy. But managing this can be chaotic. Notice the dashed lines flowing from all 3 environments down to the central, orange node labeled Azure Arc. This represents a crucial how. Azure Arc acts as a unified management control plane, allowing cloud engineers to govern, secure, and monitor resources across Azure, other public clouds, and on-premises servers from a single pane of glass. It visually reinforces that while your infrastructure can be highly distributed to meet specific use cases, your management and governance must remain centralized and coherent.